The solid brick shown is made of small bricks of side 1. When the large brick is disassembled into its component small bricks, the total surface area of all the small bricks is how much greater than the surface area of the large brick?
Oh boy.
Sounds like an algebra problem. You want to take that one?
Oh no, thanks.
This is definitely geometry, and so what we're kind of thinking about is we have a brick, and like we just mentioned, that brick is made up of a bunch of little cubes, right, kind of put together. So we want to think about what the surface area is of that brick, and consider that, you know, part of the cubes are not part of the surface, and it'll make more sense when I kind of draw this out. But think about, when we talk about surface area, what we're talking about is, imagine you were to paint the outside of this brick. Right? You wouldn't paint everything inside of it. You would just paint, like, for example, this shape, and you have a top and bottom of this, and you would paint the wall. Just think about, like, nothing inside is getting painted. You can't actually even reach it. So kind of what we have here when we talk about the surface area of this, what actually is a rectangular prism, we have really 6 shapes that make it up. We have the top and the bottom, and I'm going to sketch these separately. So you notice the top and the bottom are both the exact same dimensions, right? Because it looks like it's kind of, oh, that's not very good. It's kind of shared throughout the figure. And so I've got, it's kind of cut in half, and then it's cut into 3 pieces, or three other lengths. This is not really working out that well with these straight lines, but I'm going to keep on trying it anyways. Okay, so this is kind of what the top looks like if you just look at the 2-dimensional view of it. And what we're also told is it's made of small bricks of side 1. When we say that, what we mean is each one of these, so like this length right here is 1, this length right here is 1, and these are all identical squares in here. So think about, like, we have this on top. We also have the exact same identical thing on the bottom, so we got 2 of those. It actually looks like on the side, this is the exact same as well. So I should change this. We don't have 2 of these, we have 4 of them. And then we have 2 of these shapes right here. Let me do a different color. Right, and again, when we talk about surface area, we're really only talking about that 2-dimensional kind of flat piece of it. So this is a bit of a different size. This is more of a 2 by 2. These are clearly not to scale, but something like that. And then I'm going to cut it in half. And we're still saying the sides are of length 1, and we have 2 of these, right? So again, try to imagine if you were to put all these together, they should be able to form this shape on the outside. So these are all made of side 1, so think about, like, across here, right, we have 3 across, we have 2 down. So if I want to find the area of just one of these shapes, surface area, keep in mind, we would do the length 3 times the width of 2. We end up getting 6. But then we need to remember that we have 4 of these sides. So if one side has a surface area of 6, then 4 sides has a surface area of 6 times 4, or 24. So that is the surface area of kind of that 2 by 3 shape that makes up 4 sides of this 3-dimensional object. And then we come down here. Again, we kind of notice that these come from this side and the other side that you can't see. And these are going to be 2 by 2, because again, each one of these are a length of 1, which is going to give us 4. We have 2 of them, so a total of 8. And then if we want to find surface area, we're literally just adding them together. We get 24 plus 8. We have a surface area of 32. It just says side 1, so I'm just going to call it 32 units squared. But that's not what we're actually looking for. We want to know what would happen if I were to take this apart and make just a bunch of small cubes. And so think about like a Rubik's Cube. Have either of you ever cheated and peeled off all the stickers on a Rubik's Cube to solve it?
No.
Sam?
I'm
probably
not.
have.
I'm not a cheater like
Have
that.
I
just-
ever
You ever
pulled the cubes
peeled,
off?
Peeled the stickers off a Rubik's Cube?
No, because
so
you can
solve
actually
it?
yank the cubes themselves off of the center like spine. Just
Awesome.
click them back into place. That's how I
good
cheat.
to know.
You guys are such cheaters.
Wait, can you actually pull the three-dimensional cube
The
out?
three-dimensional cube, so it's like
Give me a better example.
especially in older ones, you can pull it out.
You could have solved it so much faster.
Yeah, it's quick. It's quick now.
Oh, you
And
guys
it's probably
are
not
such
as obvious that you
cheaters.
peeled stickers off.
And then nobody can tell that you're such a cheater.
Yeah, but anyway,
fool all
so
your
when
friends.
when Sam is pulling his Rubik's Cube apart,
So
cheating
never
with
believe
the
them
Rubik's
if they
Cube,
say they solved it.
yeah, he's actually pulling out a bunch of little cubes, if you can imagine what that looks like. And if you can't, just kind of think of this figure, right? Like this is a little cube. It's a 1 by 1 cube, 1 by 1 by 1 cube. So think about this right here is really kind of, let me see if I can sketch this. This three-dimensional cube here, right? And now when we look at this, we actually have 6 sides on this cube, right? So what we're saying is if I were to pull all these cubes out, like Sam did with his Rubik's Cube, how much surface area do all these cubes combined have? Well, if I take a look at this one, this is a 1 by 1, right, on each side, and they're all the same size. So each face, we have 6 of them, so we basically have 6 little squares that are 1 by 1. So we have 1 times 1 is the surface area of each one, and then times 6. So each cube has a surface area of 6. And then if you kind of count, we have 3 stacked across twice. So we actually have 3 times 2 times 2 cubed. We have a total of 12 cubes. And each cube has a surface area of 6. So 12 times 6 is 72. So if we look at the solid brick, it has a surface area of 32 units. But if we pull them out, we have a surface area of 72. And again, keep in mind that when I look at this cube, the reason why we have more when we pull them out separately is because you can't actually get to, you kind of notice there's a little box in here, right? But it's covered up, right? So you can't actually see it. It's not part of the surface area. And again, think about if you were painting all of that, you wouldn't paint inside. So hopefully that helps. It's kind of hard to see with these three-dimensional objects, but if you have a Rubik's Cube and you haven't been able to solve it, think about this problem. Think about Sam's solution to the Rubik's Cube, pull it apart, and think about, did they put stickers on the inside of the Rubik's Cube? No, because you can't see it, right?
Right.
Same idea.
Makes sense, except for I
Hopefully that
don't
helps.
condone the cheating. I just.
Well, it's
Look,
not cheating. It's saying,
13-year-old
can you-
me just like wasn't getting anywhere, and I had to do something.
And it says solve the Rubik's Cube. It doesn't say that you have to,
Yeah, it's like how to solve the Rubik's Cube.
whatever.
Rubik's Cubes are cool though, so
They are.
you should try to figure them out for real.
Guys, oh well.